It operates on a client-server model where the client initiates a connection to the server to upload or download files. FTP supports both anonymous access, where users don't need credentials, protocols like FTPS or SFTP are recommended. Up next, we have SMTP. SMTP, or Simple Mail Transfer Protocol, is the standard protocol used for sending and relaying email messages across networks. It operates as a push protocol where an email client like Outlook or Gmail SMTP server to send messages to the recipient's mail server. SMTP is responsible for ensuring that emails are correctly routed and delivered to the intended destination. While it handles outgoing mail, SMTP is often paired with protocols that manage the retrieval of incoming mail, like IMAP or POP3, which we'll cover later in the video. Like the previous protocols we covered, SMTP itself does not provide encryption, so security methods like SMTPS are used to protect email content from transmission. Next, let's take a look at DNS. DNS, or Domain Name System, is a crucial protocol that translates human-readable domain names like www.youtube.com into IP addresses that computers use to locate and communicate with each other on the internet. Acting as the Internet's phone book, DNS allows users to access websites using easy-to-remember names instead of complex numerical IP addresses. When a user enters a domain name into the browser, the DNS server looks up the corresponding IP address and directs the request to the appropriate web server. This process happens almost instantly, making it seamless for users to navigate the web. Coming up next, DHCP. DHCP, or Dynamic Host Configuration Protocol, is a network protocol that automatically assigns IP addresses and other network configuration parameters to devices on the network, allowing them to communicate efficiently. When a device, like a computer or smartphone, connects to a network, the DHCP server dynamically assigns an available IP address from a predefined range, along with necessary details such as the subnet mask, default gateway, and DNS server. This automated process simplifies network management by eliminating the need for manual IP address configuration, reducing conflicts, and ensuring that each device has the correct network settings to operate smoothly. Moving forward, we have SSH. SSH, or Secure Shell, is a network protocol used to securely access and manage remote servers and devices over a security. It provides a secure channel through which users can execute commands, transfer files, and perform administrative tasks on remote machines. SSH encrypts all data exchanged between the client and server, protecting it from eavesdropping and tampering. By using strong authentication methods, such as passwords or cryptographic keys, SSH ensures that only authorized users can access the remote system. This makes SSH an essential tool for secure remote administration and secure data transfer. For more information on cryptography and encryption, feel free to check out our video on that topic in the video description. Now let's take a look at TCP/IP. TCP/IP, or Transmission Control Protocol / Internet Protocol, is a foundational suite of protocols that underpins most modern networks, including Ethernet. TCP/IP enables reliable data transmission by breaking data into packets, ensuring they arrive in order, and handling any errors that occur during transmission. The IP part of the suite handles addressing and routing, ensuring packets reach their correct destination across diverse networks. Together, TCP/IP facilitates robust, scalable, and efficient communication between devices, making it essential for network connectivity and internet functionality. For a more detailed overview of IP addresses, be sure to check out our separate video. Post Office Protocol 3 and IMAP, or Internet Message Access Protocol, are two protocols that help you access your emails from the mail server. POP3 downloads emails to your device and usually removes them from the server so you can read them offline, but it limits access from other devices. IMAP, on the other hand, keeps your emails on the server and syncs them across all your devices so you can access your messages from anywhere. SMTP, which we covered earlier in the video, is used to send emails to the server, while POP3 and IMAP are used to retrieve them from the server. Together, these protocols work to ensure you can send and receive emails effectively. Coming up next, UDP. UDP, or User Datagram Protocol, is a communication protocol used in computer networks that allows for fast and connectionless data transmission. Unlike TCP, UDP does not establish a connection before sending data, nor does it guarantee delivery, order, or error checking methods. This makes UDP speed is critical and data loss is acceptable, such as live streaming, online gaming, or voice over IP services. While it's less reliable than TCP, UDP simplicity and low overhead make it ideal for real-time applications where performance is more important than accuracy. Now let's take a look at ARP. ARP, or Address Resolution Protocol, is a network protocol used to map an IP address to a physical MAC address within an open network. When a device wants to communicate with another device on the same network, it needs to know the recipient's MAC address. ARP helps by sending out a broadcast request asking, who has this IP address? The device with the matching IP address responds with its MAC address, allowing the communication to proceed. ARP is essential for enabling seamless communication between devices on a local network. To learn more about how MAC addresses work, check out our separate video, which you'll find linked in the video description. Moving forward, we have Telnet. Telnet is an older network protocol that allows users to remotely access and manage devices over a network using a command line interface. Unlike more modern protocols, Telnet does not encrypt the data being transmitted, which includes sensitive information like login credentials. Because of this lack of security, Telnet is generally considered outdated and insecure, making it less suitable for use in today's environments where security is a priority. It was briefly mentioned in our previous video on firewalls as an example of a protocol that can be easily exploited by attackers if not properly secured. Next on our list is SNMP. SNMP, or Simple Network Management Protocol, is a network protocol used for managing and monitoring network devices, such as routers, switches, and servers. It allows network administrators to collect performance data, monitor device status, and configure network hardware from a centralized management system. SNMP operates using a client-server model where the managed devices, agents, send information to a network management system, NMS, upon request or periodically. This protocol helps in maintaining network performance and troubleshooting issues, making it a crucial tool for network administration. Coming up next, ICMP. ICMP, or Internet Control Message Protocol, is a network protocol used to send error messages and operational information about network communication. It operates as part of the Internet Protocol Suite and is essential for diagnosing and managing network issues. ICMP helps in troubleshooting network connectivity problems by providing feedback on the status of data transmission. For example, tools like Ping and Traceroute use ICMP to test the reachability of network devices and to determine the path that data takes across the network. By reporting errors and network conditions, ICMP aids in maintaining efficient and reliable network operations. Next, let's take a look at NTP. NTP, or Network Time Protocol, is a network protocol used to synchronize the clocks of computers and network devices over a network. It ensures that all devices on a network have a consistent and accurate time, which is crucial for various applications such as logging events, coordinating transactions, and scheduling tasks. NTP operates by allowing devices to communicate with time servers which provide the correct time based on highly accurate sources like atomic clocks. By maintaining synchronized time across a network, NTP helps in preventing errors and inconsistencies that could arise from time discrepancies, thereby ensuring smooth and reliable operations. And lastly, let's take a look at RIP and OSPF. RIP, or Routing Information Protocol, and OSPF, or Open Shortest Path First, are two widely used routing protocols in computer networks. RIP is a simpler distance vector protocol that determines the best path for data by counting the number of hops between the source and destination. However, it has limitations in larger networks due to its slower convergence and maximum hop limit of 15. OSPF, on the other hand, is a more advanced link state protocol that uses a cost-based metric to determine the shortest and most efficient path to data. It's faster, more scalable, and better suited for complex networks. In conclusion, understanding network protocols is essential for grasping how data travels across networks, ensuring smooth communication between devices. These protocols, from basic ones like TCP/IP to specialized ones like RIP and OSPF, form the backbone of internet functionality and network management. Whether you're dealing with email, file transfers, or routing data. Knowing how these protocols work gives you the insight needed to manage, secure, and optimize your network. With this knowledge, you can better appreciate the complexity and efficiency of modern digital communication. This concludes our exploration of network protocols. If you enjoyed it, consider subscribing to our channel and liking the video. Feel free to also check out our other videos on it.
ARP stands for Address Resolution Protocol. Now this is a protocol that is used to resolve IP addresses to MAC addresses. The MAC address is a physical address of a device. It's a globally unique number that is assigned to every network interface part. Whenever a device needs to communicate with another device on a local area network, it needs the MAC address for that device. And devices use ARP to acquire the MAC address for that device. So as an example, let's say that computer A wants to communicate with computer B. Now computer A already knows the IP address for computer B, but in order to communicate with computer B, it still needs its MAC address. Now an IP address is used to locate a device on a network. And the MAC address is what identifies the actual device. So in order to find the MAC address, computer A will first look at its internal list, called an ARP cache, to see if computer B's IP address already has a matching MAC address. In fact, we can check this ourselves at a Windows command prompt by using the ARP utility and by typing ARP space -A. And as you can see in the output, it has no entries at all. The ARP cache is empty. So now computer A will send out a broadcast message out on the network asking every device that computer has will ask for the MAC address. Then the computer that has the matching IP address will then respond back and tell computer A its MAC address. Then once it receives the MAC address, the communication can now take place between the two. Now once computer A has the MAC address, it will store this information in the ARP cache. So now let's do the same commands as before, and now you can see that the IP address and matching have been added to the ARP cache. The ARP cache is used to make a network more efficient. It stores IP address to MAC address associations, so that the next time it needs to communicate with a device on the network, it doesn't have to broadcast a message out on the entire network. It can just look in the ARP
something different like that.
and there are also two different types of ARP entries. The dynamic entry is created automatically. The device sends out a broadcast message out on the network, requesting a MAC address. Just like in the example we just did. Dynamic entries are not permanent. They are flushed out periodically, so that the cache doesn't get filled up with redundant entries that are not being used. And a static entry is where someone manually enters an IP address to MAC address association using the ARP command line utility. So for example, let's create a static ARP entry. So at a command line, we will type and then the IP address followed by the MAC address. So now if we look at the ARP cache again, we would see our static ARP entry. Network administrators would use static entries to reduce any unnecessary ARP broadcast traffic on a network. For example, static entries are ideal if you know that two devices are constantly going to be communicating with each other.
Can you replay that?
Do the same exact one or like a different one?
No, the same one.
ARP stands for Address Resolution Protocol. Now this is a protocol that is used to resolve IP addresses to MAC addresses. The MAC address is a physical address of a device. It's a globally unique number that is assigned to every network interface code. Whenever a device needs to communicate with another device on a local area network, it needs the MAC address for that device. And devices use ARP to acquire the MAC address for that device. So as an example, let's say that computer A wants to communicate with computer B. Now computer A already knows the IP address for computer B, but in order to communicate with computer B, it still needs its MAC address. Now an IP address is used to locate a device on a network, and the MAC address is what identifies the actual device. So in order to find the MAC address, computer A will first look at its internal list called an ARP cache to see if computer B's IP address already has a matching MAC address. In fact, we can check this ourselves at a Windows command prompt by using the ARP utility and by typing ARP space -A. And as you can see in the output, it has no entries at all. The ARP cache is empty. So now computer A will send out a broadcast message out on the network asking every device which computer has the specific IP address and will ask for the MAC address. Then the computer that has the matching IP address will then respond back and tell computer A its MAC address. Then once it receives the MAC address, the communication can now take place between the two. Now once computer A has the MAC address, it will store this information in the ARP cache. So now let's do the same commands as before, and now you can see that the IP address and the matching MAC address have been added to the ARP cache. The ARP cache is used to make a network more efficient. It stores IP address and MAC address association so that the next time it needs to communicate with a device on the network, it doesn't have to broadcast a message out on the entire network. It can just look in the ARP cache. And there are also two different types of ARP entries, dynamic and static. The dynamic entry is created automatically when a device sends out a broadcast message out on the network requesting a MAC address, just like in the example we just did. Dynamic entries are not permanent. They are flushed out periodically so that the cache doesn't get filled up with too many entries that are not being used. And a static entry is where someone manually enters an IP address to MAC address association using the ARP command line utility. So for example, let's create a static ARP entry. So at a command prompt, we will type ARP space -X and then the IP address followed by the MAC address. So now if we look at the ARP cache again, we would see our static ARP entry. Network administrators will use static entries to reduce any unnecessary ARP broadcast traffic on a network. For example, static entries are ideal if you know that two devices are constantly going to be communicating with each other.
So Skype is better, right?
I don't pick that up.
Did you go back to it?
You kind of restarted these types of concepts like
Hey, what's up guys? Welcome to Silvers. In this video, we're going to be talking about POP.
Same video?
yeah.
So, What is ARP? ARP stands for Address Resolution Protocol, and is designed to discover MAC addresses and then map them to an IP address. So let's see how this works. In our example, we have 4 computers and a switch. Our computers will assign IP addresses 192.168.0.1.2.3.4. Let's say Steve wants to communicate with Steve. We already know the IP address. It will be typed in manually. But remember, switches are layer 2 devices using MAC addresses, not IP addresses. So for host A to communicate with host B, it somehow needs to find out its MAC address. The way it does this is simple. Host A will shout out the entire network saying, who is 192.168.0.4? Tell me your MAC address. And that message is sent to the broadcast. We've already looked at broadcast messages, and remember, they will be sent to the destination address of all X. And the switch will send this out on every interface except the one that received it. Host B and host C will look at this message again. 192.168.0.4. That's not it. And they discard correct. But when host B sees the message, he says, oh, 192.168.0.4, that's me. Here is my MAC address. And then host D replies with the MAC address directly to host A. When our computers learn MAC addresses, they are stored in a table for future use. It lists the known IP addresses and their associated MAC addresses. This table is called the ARP cache. From this point forward, host A needs to talk to host B. It just needs to look up the IP address in the ARP cache to find the correct MAC address. And now they can both set frames happily. So that was pretty simple. Let's see this live and in action. I'm going to hit the Start button and type PowerShell. Now we're going to need to run this as admin, so right click, run as administrator. Accept the UAC. And when that loads, I'm going to start by typing ARP-A. This is going to show us the computer's ARP cache. We have the internet address, which is the IP address, the physical address, which is the linked MAC address, and we have the type. This shows us if the MAC address was learned by ARP or if it's a static entry. You can see we have 3 static entries, and this is by default. The top one is something called a direct broadcast address. You should be able to recognize this by the IP address. It's the last IP of the network. You should also be able to recognize it by the associated MAC address, which is all X. This tells us this is a broadcast address. The option 2 are multicast addresses. You can see that the address is a number of MAC address. So, because my computer already knows the MAC address of 192.168.0.4, I'm going to run ARP-B 192.168.0.4, and this is going to delete that entry.
Wait, who wants it?
If I then type ARP-A again, we see that entry has been removed. Now I'm going to open up the program with Wireshark. It will recover all of the traffic on this computer. We just need to select the interface and hit the Start Capture button. While that's running, I'm going to open PowerShell again and type in 192.168.0.4. This will trigger our request. Once the ping is finished, we'll get back over to Wireshark and hit the stop button. There's not a huge amount of code here. If you're trying this at home,
Yeah, I gotta restart the video.
Alright.
You won't disconnect okay.
You just have to put that little square. Yeah, okay. Slide to the left. Slide to the right. Shut down. Yeah. Now move all to the back.
ARP stands for Address Resolution Protocol. Now, this is a protocol that is used to resolve IP addresses to MAC addresses. The MAC address is a physical address of a device. It's a globally unique number that is assigned to every network interface card. Whenever a device needs to communicate with another device on a local area network, it needs the MAC address for that device. And devices use ARP to acquire the MAC address for that device. So as an example, let's say that computer A
What's up guys, welcome to Cerberus. In this video we're going to be talking about ARP. So, what is ARP? ARP stands for Address Resolution Protocol, and it's designed to discover MAC addresses and then map them to an IP address. So let's see how this works. In our example, we have 4 computers and a switch. Our computers have been assigned IP addresses. Not 2, 3, 4. Let's say Hussein wants to communicate with Christine. We already know the IP address, then you can type it manually. But remember, switches are layer 2 devices, which use MAC addresses, not IP addresses. So for host A to communicate with host B, it somehow needs to find out its MAC address. The way it does this is simple. Host A will shout out the entire network saying, who is 192.168.0.4? Tell me your MAC address. And that message is sent as a broadcast. We've already looked at broadcast messages, and remember, they will be sent with a destination address or X. And the switch will send this out on every interface except the one that receives start the frame. But when host B sees the message, he says, oh, 192 wants to take 0 to 4, that's me. Here is my MAC address. And then host D replies with his MAC address directly to host A. When our computers get MAC addresses, they are stored in a table for future use. It lists known IP addresses and their associated MAC addresses. This table is called the ARC cache. From this point forward, host A needs to talk to host D. It just needs to look up the IP address in the ARC cache to find the correct MAC address. And now they can both set frames happily. So that was pretty simple. Let's see this live. And in action. I'm going to click the Start button and type PowerShell. Now we're going to need to run this as admin, so right click, run as administrator. Set the UAC. And when that loads, you can start by typing ARC-A. This is going to show us the images ARC cache. We have the internet address, which is the IP address, the physical address, is the link MAC address. And we have the type. This shows us if the MAC address was learned by heart or if it's a static entry. You can see we have 3 static entries, and this is by default. The top one is something called a direct broadcast address. You should be able to recognize this by the IP address. This is the last IP in the network. You should also be able to recognize it by the associated MAC address. Which is all X. This tells us this is a broadcast address. The bottom 2 are multicast addresses. You can see that the first 6 characters of the MAC address. So, because already know the MAC address of 192.168.0.4. I'm going to run R-B 192.168.0.4, and this is going to lead to that entry. If I then type R-A again, we see that entry has been removed. Now I'm going to open up a program called Wireshark, which will capture all of the traffic
Text you the Jenny video. I'll watch it on my phone.
We just need to select the interface and hit the start capture button. While that's running, we're going to run the PowerShell again.
Art,
Type
play, magic,
in 192.168.0.4. This will trigger an ARP request. Once the ping is finished, we'll head back over. There's a Wireshark and hit the stop button. A huge amount to go through here. If you're trying this at home, you will likely see a lot more information. This is a fresh PC, so not many applications are running. We can filter the capture by clicking at the top and typing ARP. Now we can see our ARP conversation happening. We can see the source and destination. Keep in mind though, Wireshark will try to resolve these MAC addresses with something a bit more frequent. If we look at the info column, here we go. You can see ARP requesting the MAC address of 192.168.0.4. With the first request selected, we can look at the bottom of the screen and see our source and destination MAC address. So host A is the source. If we select the second one down, which is the right, you can see in the info column host D is replying with its MAC address. This reply is saying, hey, that's me. This is my MAC address. If we look at the bottom, we can see host D's MAC address and the source, and host A's MAC address and the destination. And now if we go back to our Wireshark video, run ARP-A there, we can see that the entry is now Let's look at one more scenario. Here we have two hosts, a router and a web server. If host A wants to communicate with the web server, what will it do first?
355 and then
Well, if we type in the IP address of the web server, host A will compare that IP address with its own. It will look at 192.168.0.1 and 210.10, and it will realize the web server is not
actually about the crazy too that remember that next car when I go to work I barely got like 2 rides driving the whole way up there, right? And
ARP requests only happen in layer 2
taking
network.
from Spencer County,
So we can't send an ARP request to the web server.
from Spencer County
So what do?
and
Knowing it needs to get off the network, host A will apply the same ARP request, but not to the web server, for its default gateway.
chicken bad and like where like every 15-20 seconds I was logging out like and there were curvy roads with it. And then finally I got to the destination and got him and he was just like, thanks for giving me your safely, like yeah, like he's like thanks for giving me safely, but like also like telling me
Default gateway is like
it
the
wasn't
door.
safe, you know, and I
alongside the IP
So,
address.
I was told about it, and then like, I'm on there, right?
Essentially, the default data
There's a thing called C.
So, we send an up request to 192.
Anyway, and then the daddy got full.
Our request by the back address.
It's so tricky.
Most being the
Monterey,
top is request.
Monterey, right?
There's one right in there.
Monterey,
The original response to the email address, just like
but Monterey is where Vegas is right there. It's just different one. But every day,
now we have the address default data.
but every day has like not every day, but a lot of days have
So
like.
that's center.
The back address of the
10 probably
will have the IP address.
should have one.
Website.
I
The
think
original
sorry.
You have to do like a bunch of things. But anyways,
This video is
every
unbiased.
exit
This is
is
a course
a
we
phone
found
piece. Like
in the
there's
description.
Monterey right there.
Please feel free to
There's
go check
downtown.
that out.
There's Monterey, then the next one is Seaside, then the next one is Sand,
Comment, and don't forget to subscribe.
Sand City,
The support from you guys
Then
really does help.
Marina, and the next
Other than that,
exit,
thank you for
Old
watching.
and then there's Carmel by the Sea, there's Point Break, Big Sur, there's also, it's like all the every exit. So when I'm out there,
Where's like the biggest, like what area is like down there?
Pebble Beach. Pebble Beach down there. I went there too, I got lost in it. Pebble Beach. So, let me see. I don't really know. Just like, over there, like Carmel City is richer. Right? Because where we're at, it's kind of like it's kind of like, you don't get grimy, like city. Right here, Oak Grove, I'm on Double Avenue. Isis Canyon Street.
That doesn't sound good.
Iris Canyon.
No. Is it Canyon?
Ultra Mesa, I kind of sound like that.
Yeah, that doesn't sound good.
I think it sounds like San Diego.
Yeah, it sounds like just over here.
But I think Alpha Mesa is like
But
yeah.
Hey, what's up, guys? Welcome to
Oh,
Cerberus.
this is
This video,
Aqua.
we're going to be looking at cat VLANs. Okay, so VLAN stands for Virtual Local Area Network. Using VLANs, we can virtually separate our LANs into smaller chunks. But why would we want to do that? Well, there are a few reasons why we might want to use VLANs. One of the main reasons is something
Any other questions? So Venus is
it's a ghetto.
Is that- are you going to jail there? What for? You got popped in this?
No, I haven't pulled over because I really lost them. When I was driving and it was hard for mushrooms and for, I guess I had a warrant.
And I went over there and like, the Uber thing, and I got somebody off there. And then somebody took me on the road, and
I had to walk all the way from jail to the train station. It was a long ass walk. In the middle of nowhere every minute.
that takes like,
Like farming land.
if you're not in the downtown area, then
The blocks are down there. But
yeah,
like,
yeah, then it's far for everybody.
yeah.
Like,
I
our
walked
farm,
through our blocks. Luckily, I got really good.
you got places get it snapped up and put it through corn, you know what I mean? And like,
I
I'm
was
screaming
there was
over
people
here.
following me.
Oh, that's good.
They're not like here though. Not like they're going like
What do you over here they call it like not different?
here they're going and then sometimes they just go to front of the driveway.
What do you mean?
I'm not saying that. And I said that's the last one to go out. Double ratchet.
Oh, oh, like my double racket.
We have a single ratchet.
Triple racket?
Yeah.
No, they don't.
So let's remind ourselves about broadcasts. A LAN is a single area of the network. And in this case, we have a single broadcast domain created by our switch. If host A sends a broadcast, then every device will receive it. That's fine for our 4-computer network. But let's imagine each computer represents an entire password.
I thought it was a video game.
Very quickly, broadcast traffic can start to slow down a bit.
Do anything. Let's talk about clean water.
Our networks and devices. So we need a way to manage all of this traffic. One way is to add a router. This would create separate broadcast domains per interface. But it's an extra bit of hardware to purchase, install, cable, and manage. Another, more radical option is to physically split the network into separate sections. This would create broadcast domains for each department. Traffic wouldn't be sent from one department to the other, which drastically reduces our broadcast overhead. Now this option still has the issue of needing to purchase and set up new equipment, and neither one of these options is very scalable. So if we wanted to add a new department, both options would require work to set up. And we don't want to do that. This is where VLANs come in. VLANs give us all of the benefits of physically separating our network, but with the added bonus of being able to do this virtually. The traffic still behaves the same way as if it was physically split. Traffic isn't very rigid. Many other departments. And it's almost like having 4 miniature switches inside of a single one. The way this works is by assigning interfaces to specific VLANs. Only interfaces in the same VLAN can communicate with each other. In this example, finance is yellow, IT is red, sales is green, and HR is purple.
Guitar.
I'm using colours, but in reality, you'll probably use numbers such as VLAN 10, VLAN 20, etc. If wanted to add a new finance server, then we just need to assign that interface to the finance VLAN. And communication between those two interfaces is allowed because they're on the same VLAN. If we wanted to add a brand new marketing department, then we just create that VLAN and assign it. To an interface. As you can see, VLANs make it very, very easy to control broadcast domains. It's also skin. You don't need new equipment or to recode everything anytime you want to make a change. Okay, so that's the overview. Let's look at how this works. A bit more detail. Straight out of the box, Cisco and most other switches have a default VLAN. Every interface is assigned the default VLAN. So this means every interface can talk to each other. From here, we can start to make our own VLANs and split up our switch. We may want to make a VLAN called VLAN 10 and another called VLAN 20. You can add up to 4,094 VLANs. This is the maximum number that is supported. So now interface is designed to VLAN 10, we can only communicate with other interfaces assigned to VLAN 10. And it's the same for VLAN 20. VLANs aren't restricted to just one switch. We can have the same VLANs across multiple switches. This makes it very versatile and scalable. But this does leave us with a problem. If interfaces can only communicate with other interfaces in the same VLAN, which VLAN do we assign to the link between our two switches? If we leave it as the default VLAN, VLAN 10 and VLAN 20 won't be able to send traffic. If we assign it to one of our new VLANs, then only that VLAN can send traffic between the two switches. The solution is a special type of interface called a trunk. So there are two types of ports in a switch: an access port and a trunk port. The port is assigned to a VLAN, like VLAN 10 and VLAN 20 here. This is known as an access port. An access port is designed for endpoint devices to
You're pretty,
access
going there to, like, right here.
such as computers
It's
and
almost the same as going
Now,
there,
truck
like,
port
when I
send
booked the
traffic
box, as
from
long as
different
you
VLANs.
Really?
They're
They're used to send traffic
the Like,
I feel like going to very quick.
We can go to the devices.
today, yeah. For some reason, like,
This leaves us with another problem then. How does the receiving switch relate to the relay?
I'll go to, like,
The
office
whole
order.
point of the relay is to separate traffic.
Like,
So when a truck sends data,
like, one goes through the
VLAN 1,
one.
VLAN 2, VLAN 20, it needs a way to identify
Yeah, I feel like it better than
which
I've
VLAN
been born,
actually
I was born
belongs to.
with five of them.
This is done by using something called a tag.
No one walked backwards.
To understand tags, we need to take a couple of steps.
One.
Okay.
Now, most devices, including computers, do not know what VLANs are. Some devices are VLAN aware, such as iPhones, but most are not. So a computer generates a frame. It's normal. When that frame arrives at a switch, it's the switch that handles the VLANs. Then it's forwarded to the correct destination. The sending computer and the receiving computer have no idea that VLANs were used. Now, when we have multiple switches connected with a trunk port, there is an extra step. The computer sends the frame as usual. But when the switch sends a frame over the trunk port, it adds a new bit of information. This is called an 802.1q tag. 802.1 IEEE standard. It can also be called Q. This tag is 4 bytes and it contains a few bits of information. TPID, or tag protocol identifier. This is used to identify the frame as an 802.1q tag frame. It could also be ISL rarely used today. TCI, or tag control information. This contains 3 bits of information: the priority, DEI, or drop eligible indicator, and most importantly, the VLAN ID. This tag field is then read and removed by the receiving switch. So to recap, the frame is untagged when it's sent from the computer. This tag goes to the transport. It's then sent to the destination. Untagged. And our computers are again non-device. The next thing we need to talk about is something called native VLANs. A native VLAN is configured electronic interface. It's the VLAN that the switch assumes the frame is on if it arrives on a trunk port with no tag. By default, the native VLAN is VLAN 1. So let's say both of Just like before, the frame is set untagged to the switch. Now, if the switch is sending a frame across a trunk port that belongs to its native VLAN, the frame is not tagged. When a switch receives a frame on its trunk port without a tag, it will assume that frame belongs to its native VLAN, which in this case is VLAN 1. It will then forward that frame to the destination again. Untagged. So you might be wondering why we use native VLANs. And there are a few reasons why. Hubs can't read or write tags. All hubs can do is forward frames. Let's say we have a hub in the middle connected to another host. Using untagged native VLANs means we can send frames to our new host. If we didn't use native VLANs and the frame was set tagged,
If you were me and you had to route me like this again, what would you say?
then the host would just discard the frame because it doesn't understand VLAN tags.
Like a non-tech hobby, you know?
Testing?
It seems like a little too.
So, a native VLAN
They might-
is bigger
they
than
might check you.
This can lead to problems. For example, let's say we
I think paddle surfing is upset. Like boating, gambling, gambling
change
on
one side
boats.
of our traffic to have the native VLAN of 20 instead of 1. We now have two switches with different native VLANs.
Like to work on
Our
that.
computer will set the frame as
Or
before.
and say like I'm
The first switch will see the interface is assigned to its native VLAN and then forward that frame untagged across the
trying to
trunk.
like
Do you see the
thing
problem
on
here?
hard.
The second switch will assume the traffic should belong to its native VLAN, VLAN 20, and the frame will not be set to the destination computer on VLAN 1. Luckily, in real life, you'll be alerted to this type of configuration on the switch. You'll probably see a message like this, saying native VLAN mismatch. This video is part of our full Season 8 course, which can be found in the description. So please feel free to go and check that out. Don't forget to like, comment, and subscribe. Support from you guys really helps this channel grow. Other than that, thank you for watching.
I looked up the slang on the girl open part. It was well, so there's one like you know, a mechanic. There's a sheet mechanic, you know, whatever, just going, yeah, sheet mechanic. It's the only favorite, like, car girl, okay, but it's a one. Grease monkey, okay, and then girl mechanic, it's like car girl, you know, so, that's not a woman, engine, it's a, I like to get my wrench now, and it's my car, like DIY. there?
Hmm?
Is it that bad?
doesn't have an AGR bell.
But I didn't remove